Hello everybody, I'm Taryn from Taryn Game Dev, and today I'm going to be showing you how to make a color swap shader for pixel art so that we can take any sprite and change the colors and patterns very easily. I'm also going to show you how to apply unique changes to multiple sprites at once without needing to make multiple material assets for each game object. Tutorials already exist for this, but after following a few of them myself, I found that they didn't match the use case for my game, and decided to make this version that should work for any use case, regardless of if it's to swap one color or several colors or every color of the pixel art. If you can find a better method, or if one of the other tutorials works for your use case, use that. That's awesome. If it doesn't work, or if you want to give players control over the color scheme of the characters, follow this method instead. Now I'm using some sprites from freegameassets.com. Special thanks to our Patreons this month. You help give me the time and resources to make this content, as well as my own game Tales of Tall Rest. More on that later. First things first, on the left I'm going to get rid of this material, which I've already prepared, and I'll reset the pixel art back to default. When you import pixel art, by default it will look very blurry like this. That's because the default settings have filter and compression values. When you import your sprite sheet, go down to filter mode and change it from bilinear to point no filter. And that's how we get this nice, clean, sharp look for pixel art. Alright, now we should be able to make this shader. You need to have Universal Render Pipeline installed. If you don't have URP installed, it's very easy. Just go to Package Management, Package Manager, search Universal Render Pipeline and install it. Double check in your project settings, under graphics, and just make sure that there's a Universal Render Pipeline asset there. If you don't have a Universal Render Pipeline asset, just go into your project window, right click, create, rendering, URP asset. Create that, drag it up into there. Alright, so we're going to create, we're going to go shader graph, URP, we're going to use a sprite shader. You can use lit or unlit, it's up to you. For this tutorial, I'm going to use unlit. For my game, I'm using lit, but it doesn't make a difference. Let's call it color swap, and we'll open this so that we have this big screen here. Resize some of these windows to help you out. This screen is the shader graph. This over here on our left, this is all of our variables and parameters. We're going to create a texture 2D, and we're just going to call it texture 2D. Over on this side, we actually have a bunch of settings and variables for this node and this shader graph. The only thing we need to change is right here, we need to make sure that this is called underscore main text. And it needs to be spelled exactly like that. The reason we do that is that this is how materials created using this shader will find the image on the game object. For our default value, let's just give it sprite sheet itself. And now first thing we're going to do is we need to hook up this sprite sheet's alpha here. So we're going to drag in our texture, drag it here to quickly go sample 2D, and we're going to drag the alpha value out and right there. And we can see in our preview, this kind of gives us the cutout shape of our pixel art already. We can minimize this, and we can just group these two nodes together and call it alpha. Now we need to do the same thing again. Texture 2D, sample 2D, and now we need to set up some variables. We need to decide what of the original sprite we are going to change. So let's decide to change this character's dress. To do that, we're going to need 3 inputs. One for the base, one for the dark, and one for the outline. So in our variables, we're going to make a new category. I'm going to call that category in, and we're going to create 3 color nodes. Dress in, dress darker in, and dress outline in. And then at the top, we're going to make one more color, and we're going to call this color dress out. Now, because we're only using one sprite, we can use some default values for this. We're going to drag our scene to the side so that we can see our sprite. And for our dress, the default value is going to be this one, and then dress darker default value is going to be this, and our dress outline default value is going to be this color. And then for dress out, let's go for like a nice orange dress, which is what I made before. Now we need to do 2 things to make this work for every single use case, like I said before. First thing we need to do is separate these colors and replace them with new colors. So to do that, we're going to go from our sample texture 2D, group these two and call it source, and we are going to branch out and we're going to create a color mask in. Now what a color mask does is it separates an image based on a selected color. Let's grab our dress in because we want to grab all the pixels of the image that has this same color. Let's make sure to increase our range to 0.1, this is very important, and we can see very lightly that it's grabbing pixels that match the dress's color. And now that we have that, we're going to take this image, which now looks like this, and we are going to replace color, and we are going to replace the color white with our dress out color. And we can see that all of these pixels that the mask grabbed is now orange in this preview. So that's one of our pipes. We can group this and call it dress. Now we're going to do the same with the darker color as well. So from RGB4, go out, we're going to go color mask in, we're going to grab the darker color this time. Remember to change your range to 0.1 for pixel art, otherwise nothing is going to be grabbed at all. And then we're going to go out to replace color. Now this time we're not going to do the same color, but we're going to multiply the value by itself to get a darker value. So if we drag the dress out color here, multiply it, and we get a darker shade of its color. We can grab this output, put that in our 2 value, and change to white. So now we see the pixels that are dark spots have turned into our dark orange. Group these again, call it darker dress, and now finally we'll do the outline color mask as well. Grab our outline color, drag it in, set our range to 0.1, replace color in, change our white. Now we're going to do this multiplication method again, but we're going to multiply our already multiplied value. This is going to give us a very dark shade of that original color. And we can drag that in there, and that's going to be our outline. What we've done here is we have 3 masks and we've replaced the color of each of them, but now we need to apply these changes to our source image that we started with. One method I found in other tutorials uses replace color in a pipeline and just changes every pixel in one sweep. The issue here is if you give players the option to determine the colors themselves, they might pick the same color as one of your input variables. The replace color then affects different regions of the image. This can stack and suddenly turn the whole character into one color by accident. This doesn't work, and we need to apply our new colored masks onto the image. Imagine that every pixel has a value from 0 to 1, with black being 0 and white being 1. Now each color also has an RGB value that ranges from 0 to 255. Imagine if we cut our sprite in half and looked at it through the section of the cut, and then rearranged on a graph each pixel's value in color upwards like this. Now that we've created the new colors to go on top, they also have their own values in each pixel's place. And if we just added both graphs together, you would see that the sum of the 2 values wouldn't equal our desired color value, and this shader would create a completely unrelated color. So what we have to do is remove the pixels that we're masking underneath. To remove the original value, we're going to copy our source and we're going to create a new pipeline down here. From RGB4, we're going to go straight into a replace color. Now the values we need to get rid of are going to be the same as our in values. So grab dress in, and we want to make it black because black is equal to 0. So as long as these pixels are equal to 0, then we can add the new color values on top. When we masked the colors, we branched them out because we only wanted to affect specific regions of the image. We didn't want it to stack. When we're reducing these values to 0, we want this to stack. we want to affect all regions of the image that uses these colors. So we're going to chain replace color nodes. I'm going to go replace color, replace color, replace color, and we're going to target every single one of our in colors and turn them black. So now we can group this as a resetting pipeline. And once we have these two pipelines, we can add them together so we can see here in the end of our reset pipeline, the only pixels that are visible are pixels that we haven't targeted in a mask yet. And then in these pipelines, we see the pixels that we've masked have been changed to new colors. So we take our shadow pipeline and we'll plug it into an add node. And then we'll just add our outline to it. Then we're going to take that output into a new add node again, and then add our darker value to it. And we'll take that output into an add node and add our dress color. Now this final output connects to our base color node down here, and we can see straight away in our preview that this has changed the colors of all the pixels. Alright, let's save this and go back to our scene. Right click on our new shader that we've made, go create material. I want to call this one color swap. And we see in our material we have these variables here that we can change. And then on our left sprite, let's just drag on our new material, and we see immediately that there's a change. We can go into the material and we can change our variables as well. Now we don't want to change the in variables because we based them off of the sprite that we're using to begin with. You can change these if you're using your own sprites. Make as many pipelines as you want, just keep the resetting to black pipeline all in one straight line. I'll throw up a screenshot of my shader in Tales of Taurest because I'm changing about 20 plus colors. The reason we use the multiplication method is so that we only have to change this one color variable to get different effects. So as long as we pick this one base color, it will automatically determine the darker color values needed to change the other values. So we can make it purple, we can make it red, we can make it orange, green, kind of like a leaf mage, and we see that it all scales to what we need. We can go blue, aqua, dark blue like a deep purple again. Now we have two sprites, so let's add this material to this right sprite as well. Now say you only want to change the colors of this one. If you click on this sprite, go into its material and attempt to change it, you'll notice it changes the color patterns for both. This isn't what we want, and we don't want to have to make a new material for every game object. So go back to the original material that we made, and in our advanced options we can toggle enable GPU instancing. Now what that means is we're going to use a script to control the color swapping effect without making new materials. This script will only change the color of the sprite that is on the same game object as the script. We're going to go right click, create mono behavior script, and we're going to call it color swap controller. Open up our script, and we're going to get rid of these two functions. Now that we have this script, I'm going to show you how to edit colors for an image component and a sprite renderer component. We're going to put our color swap controller on our game object that has the image component as well. And first things first, we're going to want a public color, and this is going to be underscore new color. And then we're going to have a private image. Then we're going to go void start. We're going to get the image on ourself, and we're going to make a public void change color image. Now above this method to test it, we're going to make a context menu attribute, and we're going to call it image set. Now in our change color image method, we're going to make a local material matte, and we're going to instantiate a clone of the image's current material. Then we're going to go matte, copy matching properties, and we'll pass in our image material again. So we've created a new material based off the material that's already on the image, and we're just copying all the properties we can from that material onto our new one. Then we're going to go matte set color. And we need to give a name and a new color. Now when we set up our shader graph, this is also the reason why we only did one out color. We want to edit this color's value. So if we check this color variable and look at its reference, it's underscore dress out. Let's go into our code, and the name of the color we want to change is underscore dress out. And the color we want to change it to is our underscore new color. Then let's set material to this new material that we've made. Save that. We'll jump back into Unity, and we'll see on our color swap controller, we've now got a variable for this new color. Let's make it that nice leafy green color we saw earlier. Make sure the alpha is set at 1. And now when we enter play mode, we're getting a small issue where the alpha's not behaving properly. This is an easy fix. Go into our color swap shader, and in our graph inspector, we go to graph settings, and just make sure that we click that alpha clipping is on, and save our shader. That gets rid of that, so we're all good. Go to our color swap controller, right click it, and we see our context menu option image set. And when we click that, the single sprite changes. That's the method for changing on an image component at runtime. In our scene, we're going to make an empty game object, and we're going to add a sprite renderer. We'll just set this to vector3.0, focus in on it, and give it the same sprite. Same as before, we take our new color swap material, drag it onto our sprite, and we get the same effect. And now that that's set up, let's just add our color swap controller component again, and we'll edit this script so that it can do both. So above we're going to go public bool, and we'll say using sprite renderer. This is public so that you can use other scripts to affect the logic around it. It's not 100% necessary, but it's just good code. I'm going to make this equal to false, and we'll have a sprite renderer. We can add a tooltip attribute to this. If we are using a sprite renderer or not. If false, use an image component instead. So now in our start method, let's also go sprite renderer get component sprite renderer. And then if image is equal to null and sprite renderer is equal to null, then we want to log an error. We have nothing to change. We'll minimize our start method and we'll make a new void. Public void change color sprite renderer. Minimize this one as well. Alright, so now in here we need to make a new property block called a material property block. And we'll call it as such. And in our change color sprite renderer method, we're also going to put in another context menu attribute called sprite set. In the function, we're going to go to material property block equals new, and then we're going to go material property block dot set color, and just like we did with our other one, we're going to go underscore dress out and new color. And then we go sprite renderer dot set property block, and we pass in the property block. And then if we go to our sprite, we need to make sure we're clicking using sprite renderer, and then right click and go sprite set, and we see it changes. Now I don't like this color, so I'm just going to make this a little bit darker. Get a nice green. We have made a mistake here. Even though it is working, we have made a mistake. And that is, sometimes when we're using a material property block, sometimes the new property block sets some values to null as the default. And as a result, that means that the image might disappear completely. So when we're using material property blocks, we just need to make sure that we also include these methods as well. Material property block set color, and this one is unity underscore sprite color. And we want to make sure that it's color.white. Then we're also going to do material property block set vector. It's going to be unity underscore sprite props, spelt exactly as I've spelt it. It's going to be equal to a new vector 4, 1, 1, negative 1, 0. Now this fix won't be necessary for everyone, but if you're applying the property block and the image disappears completely, This is the fix. Now in our start method, we can go if using sprite renderer, then we're going to change color sprite renderer. Else, we can go change color image. And that's the script done. So now let's turn our canvas back on to see these two. Go to the one on the left. Let's make it a nice blue color. And we're going to go right click image set. And we see that we get a new blue character. And then we can just go straight to the source on our material and change it there. And it's going to change any of the game objects that are affected directly by the material. These two are affected by GPU instancing, so you don't need to make new materials to change their colors. You can just use the script we made. But they are going to have different colors. This video is brought to you by Tales of Tourist. Not really, but really. I make game dev content on Patreon, and those earnings help me to work on my own project, Tales of Tourist. Tales of Tourist is a JRPG that immerses the player in a living world. You can support me on Patreon for the small price of 1 Red Bull a month, and in return, you get access to behind-the-scene posts, access to videos weeks before they're live on YouTube, as well as requesting video topics and D&D homebrew content. I'm Taryn from Taryn Game Dev, and thank you so much for watching.